Okay, now given the vertices and foci of a hyperbola centered at hk, we want to write its equation in standard form. And so determining whether the transverse axis is parallel to the x or the y axis. If the y coordinates of the given vertices and foci are the same, then the transverse axis is parallel to the x-axis. And you're going to use the following standard form. If the x coordinates of the given vertices and foci are the same, then the transverse axis is parallel to the y-axis, and you're going to use the following form. Number 2, we can identify the center of the hyperbola, hk, using the midpoint formula and the given coordinates for the vertices. Number 3, you're going to find a squared by solving for the length of the transverse axis 2a, which is a distance between the given vertices. Step number 4, we're going to find c squared using h and k found in step 2, along with the given coordinates for the foci. Step 5, solve for b squared using the equation b squared, which is equal to c squared minus a squared. And number 6, substitute the values for h, k, a squared, and b squared into the standard form of the equation determined in step 1. Now in example number 3, we're finding the equation of a hyperbola centered at hk, given its foci and vertices. What is the standard form, the equation of the hyperbola, that has the vertices 0, negative 2, and 6, negative 2, and foci at negative 2, negative 2, and 8, negative 2. Now, the y-coordinates of the vertices and foci are the same, so therefore the transverse axis is parallel to the x-axis. Thus, the equation of the hyperbola will have the following form. X minus h squared over a squared minus y minus k squared over b squared, which is equal to 1. Now first, we identify the center hk. The center is halfway between the vertices 0, negative 2, and 6, negative 2. Applying the midpoint formula, we have the following. So the x-coordinates are 0 and 6. We add those and divide by 2. So 0 plus 6 divided by 2 gives us 3. And then we take the y-coordinates, which is negative 2 and negative 2, add those together, which is negative 4. Divide that by 2 gives us negative 2. So now we know the center is located at 3, negative 2. Next, we have to find out what a squared is. Now, the length of the transverse axis is 2a, and it's bounded by the vertices. So, we can find a squared by finding the distance between the x-coordinates of the vertices. So, 0 minus 6 is, the absolute value is positive 6 because we're taking the distance. 2a is equal to 6, divide both sides by 2, now a is equal to 3. And then if we square both sides, we know that a squared is equal to 9. Now we need to find c squared. Well, the coordinates of the foci are h plus or minus ck. And so we have h minus ck, which is equal to negative 2, negative 2. And then we have h plus ck, which is equal to 8, negative 2. So we can use either of these two formulas, given the value of h, to solve for c. So we can use the x-coordinate from either of these points to solve for c. Using the point 8, negative 2, we're going to substitute h to be positive 3. So h plus c is going to equal 8. Substituting the value of 3, we get 3 plus c is equal to 8. Subtract 3 to both sides. C is equal to 5, and therefore c squared is equal to 25. Now, if we wanted to use the other formula with the other point, we would have h minus c, which is equal to negative 2. We'd subtract 3 to both sides, we get negative c is equal to negative 5. Divide both sides by a negative, now c is equal to 5, and again we get c squared is equal to 25. So you can use either one of those to get that result for c squared. And next we need to solve for b squared using the equation b squared is equal to c squared minus a squared. We get 25 minus 9, which is equal to 16. So now we know that b squared is going to equal 16. And then finally, we're going to substitute the values that we found for hk, a squared, and b squared into the standard form of the equation. So we have x minus 3 squared over 9 minus y plus 2 squared over 16, which is equal to 1.